today we will see the range of function. Range of a function. Now, what is range of a function? So, you write a function as y equals to f of x, and here x is nothing but domain of a function, and your y is called range of a function. Range of a function. So what range of a function really means? Range of a function means कि in what interval will the value of y vary. y की वैल्यूज कहाँ से कहाँ तक होंगी. This is what range is. Range in general is the interval in which values of y lie. So this is called range of a function. Means there would be some maximum value of y, there would be some minimum value of y. तो जो वैल्यूज होंगी y की वो मैक्सिमम और मिनिमम के बीच ही होंगी, and that interval we will call as range of a function. So let us take examples. So let us solve our first question where y equals to 1 upon 1 plus x square. So if you see, we have to find the values of y. In which interval will the value of y lie? So see, what we need to do, we need to find the maximum of y and then minimum of y. Now, in order to find the range of a function, we will have to find the maximum value of this function and the minimum value of this function. So let us first consider finding the maximum value of this function, maximum of y. So if you see, y depends on this term x square. If x square increases, this whole denominator increases and the overall fraction decreases. If x square decreases, this denominator decreases and the overall function increases. तो y maximum कब होगा? y maximum कब होगा? जब y is maximum जब this denominator is minimum. When this denominator, that is 1 plus x square, is minimum. और 1 plus x square minimum कब होगा? 1 plus x square is minimum when x square is minimum, isn't it? And minimum value of x square, you know, x square is a non-negative number. It is a square of any number, so it must be a non-negative number. So अगर ये non-negative number है तो minimum value of a non-negative number can be 0. So x square, minimum value of x square, minimum value of x square is 0. This means the minimum value of 1 plus x square is 1 plus 0, that is 1. Therefore, the maximum value of y is 1 upon 1 plus 0, that is 1 itself. So maximum value of y is 1. Now let us see what is the minimum value of y. Minimum of y. So minimum of y will be when this term, when this denominator becomes maximum, then y will become minimum. So y is minimum when your denominator, that is 1 plus x square, is maximum. And so 1 plus x square is maximum when your x square is maximum, and the maximum value of x square can be infinity, right? The maximum value of x square is infinity, tends to infinity. So when x square tends to infinity, 1 plus x square also tends to infinity. This means 1 upon 1 plus x square tends to 0. Thus minimum of y is 0. This means that the function y equals to 1 upon 1 plus x square varies between 0 and 1. So how will we show this mathematically? Y belongs to 0, 1. Now how will we put the brackets? So at 1 we will put a square bracket. Why? Because when we put 0, then y becomes 1, and 0 is in the domain of this function. You can see that 0 is in the domain of this function. So when we put 0, we get y equals to 1, so y is included. 0, when does the value of y becomes 0? The value of y becomes 0 when x becomes infinity, and infinity is never included in the domain of any function. We always put a small bracket in front of infinity to show that infinity is not included in any domain. Thus, as infinity is not included in any domain, the value of y corresponding to x equals to infinity should also not be included. So 0 will not be included. So your y belongs to 0 to 1, 0 to 1, where 1 is included and 0 is not included. So this is the range of this function. So this is one of the most simplest problem you'll ever come across. So let us now go for next questions. There is one more way in which you can find the values of y or the range, but that cannot be used at many places. But let us see what exactly that method is. Let us see that this is a function y equals to x minus greatest integer of x. You must be familiar with greatest integer of x. So I'll talk about this also when I solve the question. And 1 minus greatest integer of x plus x. So now first look at what greatest integer is. So greatest integer of x is defined as the largest integer which is less than or equal to x, less than or equal to x. So what will be the greatest integer of 2.5? So what we have shown, greatest integer of x is defined as the largest integer which is less than or equal to x. So what is the largest integer which is less than or equal to 2.5? So the largest integer which is less than 2.5 is 2. So the greatest integer of 2.5 will be 2. Similarly, what is the greatest integer of 4.7? So the greatest integer of 4.7, that is the largest integer which is less than 4.7 is your 4. If you find the greatest integer of 4 itself, then the largest integer which is less than or equal to, see both these cases are there, less than or equal to x. So less than or equal to, this means which is the integer which is less than or equal to 4, it is 4 itself, because we also have this equal to logic. So this is how simple greatest integer function is defined. Now let us see this, the greatest integer of negative 5.7. So what greatest integer is, it is the largest integer which is less than or equal to x. So the largest integer which is less than negative 5.7 is negative 6. So the greatest integer of minus 5.7 will be minus 6. This is how you do. So one more information I'll like to give, that any value x can be written as the sum of its greatest integer plus sum of the fractional part. This is called a fractional part function. So this is called a fractional part function. Fractional part function. So this is actually fractional part of any number. So let us see that let us see a number 5.6. So what will be the fractional part of this? This will be 0.6, because we have 5 plus 0.6. 5 is the greatest integer function, that is 5 is an integer, and 0.6 will be the fraction. Similarly, what will be 6.4? What will be the fractional part of 6.4? It will be 0.4. Similarly, what will be the fractional part of minus 5.7? So here you should be careful, because the integral part of this function is your negative 6. The integral part of this function is negative 6. You can see here. So the fractional part must be your 0.3. How did you come to know this? You can see this relation. Any number can be written in the form of its greatest integer and fractional part. So let us use this relation, x equals to the sum of its greatest integer function plus its fractional part. So negative 5.7 can be written as the greatest integer of negative 5.7 plus the fractional part of negative 5.7. So this is equals to, so I have already shown that the greatest integer of minus 5.7 will be minus 6, because minus 6 is the largest integer which is less than or equal to negative 5.7. So this will be negative 6 plus, let us write it as it is. This gives us 6 minus 5.7, which is negative 5.7, least which is fractional part of negative 5.7. This comes out to be 0.3. This is how, so this is how we got the fractional part of negative 5.7. So the fractional part of negative 5.7 is 0.3. So this is a very important relationship where any number can be written in the form of the addition of its greatest integer and its fractional part. So the question on our hand is y equals to x minus greatest integer of x 1 minus greatest integer of x plus x, isn't it? X minus greatest integer of x 1 minus greatest integer of x plus x. This is the function on our hand. Now what we can write this as y equals to x minus upon 1 plus x minus this. If you see, x minus greatest integer of x gives us this fractional part of x. So we get the fractional part of x upon 1 plus fractional part of x. So this is actually y. The question is actually this. And one more thing which I would like to share, the fractional part of x should be less than 1 and should be greater equal 0. Fractional part of 1 should vary between 0 to 1, where fractional part can be 0 if the number is an integer. Let us say the number is 2. The fractional part of 2 is 0 itself. But it varies between 0 and 1, and it cannot be equal to 1. Now, this is our function. This is our final function which we need to find the range of. So we need to find the range of y equals to fractional part of x upon 1 plus fractional part of x. So in this method, what we do, we represent x as a function of y. Here it is written as y as a function of x. Now we will write as x as a function of y. We will denote x in terms of y. So let us do this. We will cross multiply 1 y into this equals to this. This gives us y plus y of fractional part equals to fractional part of x. This gives us y equals to fractional part of x minus y into fractional part of x. This gives us y equals to fractional part of x 1 minus y. This gives us y upon 1 minus y equals to fractional part of x. So this is what we got. We have got fractional part of x in terms of y. So this is what we need to do in this method. In this method, if a function y is given in terms of x, we find x in terms of y. So we have found x in terms of y. Now we know that this fractional part varies from 0 to 1. So this value y upon 1 minus y will vary from 0 to 1. Okay, so let us solve this inequality one by one. Y upon 1 minus y should be greater equal 0 and y upon 1 minus y should be less than 1. So these are the two inequalities, and this should be performed in AND operation. It should be performed in AND operation. So we know wavy curve method. It can be written as, if you see, it can be written as y minus 0 upon 1 minus y greater equal 0. So we know wavy curve method. Let us suppose this as any function, this y minus 0 upon 1 minus y as a function, and let us suppose this as some h of y here. H of y is your y minus 0 upon 1 minus y, and we what we can show it as h of y equal to some L of y upon m of y. We then find the zeros of L of y and m of y. So zeros of L of y and m of y, and m of y are your 0 and 1 respectively. Then we'll represent these zeros on a number line. So let us represent 0 and 1 on a number line. Now we will choose a number greater than the largest 0. So the largest 0 here is 1. So we'll choose a number greater than 1. Let us choose it to be 2 and find the value of this function h at 2, that is h of 2. So h of 2 will be L of 2 upon m of 2. This comes out to be y upon 1 minus y. So this is 2 upon 1 minus 2. This comes out to be negative 2, and negative 2 is less than 0. So we will put a sign negative here. Now when we cross 1, this term 1 minus y will be in picture, and 1 minus y has a power of 1, that is an odd number, and when the power is odd number we change the sign will change from negative to positive here. Similarly, when we cross 0, then your this term y minus 0 will be in picture, and the power of y minus 0 is 1 itself, that is an that is an odd number. So when the number is odd, what we do, we change the sign again. So we have changed the sign from this, here it is positive, so we will change it to negative. So now we have got the intervals of y. We satisfy this condition, y minus 0 upon 1 minus I greater or equal 0. So y upon 1 minus y is greater or equal 0 for 0, 1. Now if you see how will we put the sign, if we put 0 here, then it will be 0 upon 1 minus 0, that is 0. This means that y is should be included. If we put 1 in h of y, then this denominator vanishes, which should not be the case. Therefore we will not include 1. So this is the value of y from this case, that is y upon 1 minus y is greater or equal 0. Now let us look at the second case, which is y upon 1 minus y less than 1. So we will write it as this, then then y upon 1 minus y minus 1 minus y less than 0. This gives us y minus 1 plus y upon 1 minus y less than 0. This gives us 2y minus 1 upon 1 minus y less than 0. We will do similar things. Let us put and everywhere so that we don't have any confusion at the end. So we'll use the wavy curve method again. So the zeros of 2y minus 1 and 1 minus y are 1 upon 2 and 1 respectively. Now we will put these zeros on a number line. So the zeros on a number line can be put as this. Now we will choose a number greater than the largest 0. So the largest 0 here is 1. So let us choose a number, and that number can be anything greater than 1. So let us choose 2, and we will put 2 in this function. So when we put 2 in this function, this gives us 2 into 2, that is 4 minus 1, 3. 3 upon 1 minus 2, that is negative 1. So 3 upon negative 1, that is negative 3. And negative 3 is less than 0. So we will put a negative sign here. Now when we cross 1, we will be dealing with 1 minus y, and the power of 1 minus y is 1 itself, and 1 is an odd number, so sign will change. When we cross 1, the sign will change from negative to positive. Now when we cross 1 by 2, then this term 2y minus 1 will be in picture, and the power of 2y minus 1 is 1 again, and 1 is an odd number, so sign will change again. So here sign was positive, when you cross the sign becomes negative. So now for this term to be less than 0, y should belong to 1. So this term has to be less than 0, so y belongs to negative infinity to 1 by 2. And will we include 1 by 2? Let us see. If we put y equals to 1 by 2, this term becomes 1, so 1 minus 1 is 0. This becomes 0, but this should be less than 0. This should not be equal to 0, so we will not include y. Similarly, will we include 1? If we put 1, then this denominator vanishes, which should not be the case, so we will not include 1 again. So 1 to infinity. So this is the interval of y which satisfies this condition. Now we have seen that both these conditions should be satisfied simultaneously, that is, they should be operated in AND operation. So we will find the intersection of these two sets, because when we do AND operation we have to take intersection of sets. So let us take the intersection of sets. So for that, first represent both these sets. Let us denote 0, 1 by 2, 1, it is positive infinity here, it is negative infinity here. So now let us represent these two sets. First let us represent this one. So 0 to 1 excluded, 1 is excluded but 0 is included, so let us draw a closed circle at 0. Similarly, let us represent this set. This is minus infinity to 1 by 2, and 1 by 2 is excluded, so let us draw a open circle, and then 1 to infinity. So what are those elements which are common to both the sets? So these elements are from here to here, and that's it. This part only has the common elements. So when we take intersection of these two sets, this and this, y comes out to be 0 to 1 by 2. And 0 will be included because 0 is present in both the sets, in this set also, in this set also. But 1 by 2 will be excluded because 1 by 2 is present in this set only and not in this set. So this gives us y belongs to 0 to 1 by 2, and this is the range of this function. So y belongs to 0 to 1 by 2. So the biggest disadvantage of this method is that if we have a function of y in x, we will somehow make it a function of x in y. So y is represented in the form of x. Somehow we operate on that function and make x in terms of y. But this is not always possible. There are many functions in which you will not be able to represent x as a function of y, and these methods cannot be used there. So this is a very simple method which can be applied to some problems only. This can not be applied to multiple problems, and you'll find very few problems where you can apply this method. Mostly you'll have to go with this method which I have used earlier, where I have used the maxima and minima of x itself. And another method, which is going to the most important method, is the concept of maxima and minima, which you will study when you study application of derivatives. So there you will study how do you find the maxima of a function or minima of a function, and with the help of that you will be able to find the range of a function. So, but that would take time because we have not yet reached the application of derivative. So you should consider one thing, that we will deal really good range problems when we're done with that application of derivative. after that you'll get to see that there are a variety of questions on range. For now, let us just get an essence of what actually range is, and for more depth we will first complete application of derivative and we will then solve many questions. So for time being, let us consider a few more questions which will be solved without using the concept of maxima and minima. So let us take this function ln y equals to ln 3x square minus 4x plus 5. So this is a function and we have to find the maximum, that is the range of this function, that is the value of y which lies between the maxima and minima of this function. So you will see that ln is actually log of e 3x square minus 4x plus 5, and you plot the graph of log as this. Let us plot the graph something like this. So as x increases, as x is increasing, the value of y is also increasing. This is y log e x. So as x is increasing, your y is also increasing. So the maximum value of y will be at maximum value of x. So the maximum value of x will give you the maximum value of y. Similarly, in this question, the maximum value of y will be given by the maximum value of this quantity 3x square minus 4x plus 5. So now we have to find the largest value of 3x square minus 4x plus 5 to get the largest value of ln 3x square minus 4x plus 5. So how will we get this? Let us write 3x square minus 4x plus 5 in terms of, let us take 3 as common. We will change it into perfect square and then we will easily see what is the smallest and the largest value of this function. So this will be 4 upon 3x plus 5 upon 3. This question can be done very easily with the help of your maxima and minima, but we have not learned the concept of maxima and minima yet, so we will do it using perfect square method. So we will write it as 3x square minus 2 into 2 by 3 into what we do, x square minus 2 a b. Here a is x and b is 2 by 3. So a square minus 2ab plus b square. So b square will be, we have added this, so we will also subtract this, and then 5 upon 3. Now let us write it as x3 into x minus 2 upon 3 whole square plus 5 by 3 minus 4 by 9. Now let us write it as x minus 2 by 3 whole square plus 9. This is 15 minus 4, 11 upon 9. This comes out to be 11 upon 9. So what will be the maximum value of this function? This function comes out to be this. I mean, this function 3x square minus 4x plus 5 can be written in this form. So what will be the maximum value of this function? So you see, this term is a square term. It can be 0 or greater than 0. And similarly, this is a constant. So the value of this function will depend entirely on this term, x minus 2 upon 3 whole squared. So the maximum of your 3x square minus 4x plus 5 will be when x minus 2 upon 3 whole square becomes maximum. So the maximum of this value will be given by the maximum of x square minus 2 by 3 whole x minus 2 by 3 whole square. So the maximum value of x minus 2 by 3 whole square is infinity, because this is a non-negative term. It can vary from 0 till infinity. So maximum of 3 of your x minus 2 by 3 whole square is infinity. So as x minus 2 by 3 whole square tends to infinity, this term x minus 2 by 3 whole squared plus 11 by 9 also tends to infinity. Thus the maximum value of 3x square minus 4x plus 5 tends to infinity. So the maximum value of log of e 3x square minus 4x plus 5 will be nothing but log base e infinity, because you have seen that when we draw log of or ln of x, it is y ln of x and it is x. So as x increases, your ln x also increases and it becomes maximum when x is maximum. So similarly, this term log of base e 3x square minus 4x plus 5 becomes maximum when 3x square minus 4x plus 5 becomes maximum, and the maximum value of 3x square minus 4x plus 5 is infinity. So the maximum value of this term is log base e infinity. This gives you a value nothing but infinity, because if you see from this curve, as the value of x is increasing, log is also increasing, and it will tend to infinity when x becomes infinity. So this is the maximum value of your function. The minimum value can be found minimum of ln 3x square minus 4x plus 5 will be found when 3x square minus 4x plus 5 is minimum. So if you see this term, then what will be the minimum value of this term? See, this is a non-negative number. This is either 0 or greater equal 0. So this term will be minimum when this value is equal to 0, because if it is not equal to 0, it will be greater than 0. So we will find the minimum when this term becomes 0. So minimum of 3x square minus 4x plus 5 is found when your this term x minus 2 upon 3 square equals to 0, and when this becomes 0, the function becomes, that is 3x square minus 4x plus 5 becomes 3 into 0 plus 11 upon 9, which is 11 upon 3. Smallest value of 3x square minus 4x plus 5 becomes 11 by 3, and as we have seen that the minimum value of 3x square minus 4x plus 5 will be used to find the minimum value of ln 3x square minus 4x plus 5. So the minimum of ln 3x square minus 4x plus 5 will be nothing but ln 11 upon 3. So 11, this is the value. So y belongs to 11, ln 11 upon 3, which is the minimum value to infinity. And I think you will be able to figure out why we have used the square bracket here and the open bracket here. So for time being, let us stop here. This was just an essence of what function is, and you can always practice. Now, if you go and solve JE problems, you might face some problem because they ask questions where you'll have to use that concept of application of derivatives, but we have not actually studied it yet. So you might face some problem, but you can solve basic problems right now. And if you solve basic problems, you'll find it easy to solve. So we will look at range of functions in greater detail when we study the concept of application of derivative. So for time being, that's it. Thank you.